everybody. Bradley Rita here. Welcome to Algebra 2. Today we're going to be talking about starting Chapter 6, which is going to be exponential functions and logarithms. But we're going to start off today with Part 1 of Chapter 6.1, and this is going to be about exponential growth and decay. Primarily, we're going to focus on graphing today, and then the next lesson, Ms. Galindo is going to hook you up with some modeling and some real-world scenarios there. So our learning target for today is I can describe and evaluate exponential growth and decay from an equation or a graph. First, we need to figure out what exactly an exponential function looks like, whether it's growth or decay. And there are some primary parts that we need to be aware of here. Oops, so I kick my paper around right here. The first we're going to talk about is this A value out here. This isn't always included. This is your y-intercept. It's not always written, and you're going to see why it's not always written in a few moments here. This x, this is right here, is your exponent. This is what we're going to be substituting in here. That's the value that's going to be changing. And then b is our growth slash decay factor, okay? And that's going to be based on what is either growing really, really fast or shrinking really fast. Okay? The first one we're going to do is what happens when this value b is larger than 1. You'll notice it doesn't equal 1. It is larger than 1. When this happens in this parent function here, f of x equals b to the x, this represents exponential growth. Okay? When b is larger than 1, it represents growth. So an example of an equation where that would happen, or for a function like that, it would be something like this. F of x equals 2 to the x. Okay. What we're going to do is we're going to take this base, okay, and we're going to evaluate for each of these inputs here. So we're going to evaluate here for 2 to the negative 2, and then 2 to the negative 1, 2 to the 0, 2 to the 1, and then 2 squared. Okay. So your calculator, even though these are not the most complex here, your calculator can be very helpful for you, and you'll need to remember as I load my your calculator here. Your calendar will not help you on this. Your calculator right here, right? Well, we can take all of these bases and we can raise 2, and we know that this button right here will raise it to whatever power we want, and we can raise it to the negative 2, and we hit equals, and we get 0.25, right? Well, we know that also as, let's see, 0.25. We also know that to be 1/4, because we remember our rules for exponents that 2 to the negative 2 means we're going to take this base, we're going to move it to the opposite part of the fraction where it's currently located. Right now it's a numerator. It would be a denominator, and then this would turn positive, so it'd be 1/2 squared. Well, 2 squared is 4, so it'd be 1/4. Okay. So we'll do the same thing here. 2 to the negative 1. If you're unsure, use your calculator. That's fine. Okay. 2, raise it to the negative 1 power, and we get 0.5, or 1/2. Okay. Now these won't always simplify to nice, easy fractions here, as at least easy in your head. But when you get these decimals, they should look familiar to you. You should be able to equate 0.25 to the 4th and 0.5 to 1/2. And then get 2 to the 0. 2. Raise that to the 0 power, and you get 1. Remember, that is 1. It is not 0. Okay? 2 to the 0 power is just 1. And then you get 2 to the 1st power. That's going to be 2. And then 2 squared, and that's going to be 4. Okay? So we have our values here that we're going to graph. At negative 2, 1, 2, we're going to go up 1/4. So we're just going to put a point right there. That's close enough. At negative 1, we're going to go up 1/2. Here's negative 1. We're going to go up 1/2. Okay. At 0, we're going to go up 1. At 1, we're going to go up 2. And then at 2, we're going to be at 4. 1, 2, 3, 4. Okay. We'll connect these now with a nice smooth curve. It goes like this, right here, and it starts to go up considerably. Okay. If we were to add a 3 here, this would be 2 to the 3rd, and that would be 8. And so at 3, we would be way up here, we would be at 8. Okay. So you can see how this starts to grow really, really fast. Well, our domain here is this symbol. Okay. Remember, that means that all real numbers. We can put in any number we want into our exponent up here. Okay. Any real number we want. Now our range is going to be limited because that's going to be the outcomes here. You'll notice that as this goes up, it's going to go up and up and up and up and up. It'll keep climbing infinitely. Okay? Whereas we go backwards, if we follow it here, we notice that it starts to bottom out. It starts to flatten right here. Well, our range is this. With this parent function, our range is y is any number greater than 0. That could be a valid number. Okay? But you'll notice this isn't y is greater than or equal to 0. This is y is greater than 0. That's because there's an asymptote at y equals 0. No matter what number we put into here, okay, into our exponent, we cannot get to 0. We can get really, really close, but we cannot get to 0. No matter how small of a number we put in, you put in negative 1,000,000, you're still not going to get 0. And then our y-intercept, we can tell this by one of two ways. One, we can look at the graph and see where it crosses the y-axis. And as we look right here, we can see that it crosses the y-axis right here. Okay. So that's a value of 1. Y equals 1. We also know, as we talked about up here, that the y-intercept is whatever value is in front of our growth and decay factor. Well, the number in front of this 2, it's not really written there, but there is a 1 right there. And so that is our y-intercept as well. Okay? And because this graph, as we look at it from left to right, we see that this is increasing. This is exponential growth. Well, the opposite of exponential growth is exponential decay. Okay? And this happens when b is greater than 0, but it is less than 1. Okay? This is our base value here. B needs to be between 0 and 1. So something like this. We'll do 1/2, and we'll raise it to the x power. So 1/2 is between 0 and 1. And we'll do the same thing we did in our table up here where we had f of x equals 2 to the x. Is we'll take 1/2 and we'll raise it to -2. And then 1/2 we'll raise it to -1, 1/2 to 0, 1/2 to 1, and then 1/2 to 2. My fraction lines aren't showing up there. Let me make sure that they really show up right there. Okay. Now you can put these into your calculator if it's a number that can be represented as a fraction, or you're familiar with how to do that. In this case, we can do 0.5. Okay, I can take 1/2, I can take 0.5, and I can raise it to the -2 power. And I'm going to get 4. Okay, I can take 1/2, and I can raise it to the -1 power, and I get 2. 1/2 to the 0, anything to the 0, I don't care what it is. This is going to be 1. 1/2 to the first power, that's just 1/2. And then 1/2 squared. We can do this in our calculator. We can do 0.5. We can raise it to the second power, and we get 0.25, okay, which we also know is 1/4 Real quick though, we also know that 1/2 to the second power, if remember our properties of exponents here, it gets distributed here and here. So 1 squared is going to be 1, 2 squared is going to be 4, and that's where we get the 1/4 right here. By the same token, if you have this 1/2, okay, to the -2, that means this. Okay, this can get distributed here and here, so it's going to be 1 to the -2 over 2 to the -2. Remember that when we have negative exponents, in order to resolve these, we're going to take the base, we're going to move it to the opposite part of the fraction, and then we're going to simplify. So this 1 to the -2, this is going to move down here, and then it'll be positive. And then this 2 to the -2, this will move up here, and then that will make that exponent positive. Now we have 2 squared over 1 squared. 2 squared is 4. 1 squared is 1, so we get 4. Okay, that's how we did that right there. Well, now that we have our values, we can go ahead and graph these. At -2, our value is at 4. So here's -2, 1, 2, 3, 4. Here's -1, 2. Here's 0, 1. 1, 1/2. And then 2, 1/4. And again, we'll connect these with a smooth curve. I'll do my very best here. And there we go. So it starts to flatten out right there. As we look at this, we can evaluate our domain again is going to be this symbol right here. All real numbers. We can put in any number we'd like for the domain. Any real number can go in as this exponent, no problem there. Our range, as we're looking at this graph, okay, our range is going to be any number larger than 0 again, okay, because we have this asymptote. We have this asymptote where we are approaching this line, but we're never quite going to reach it. Okay, and that asymptote right here again is y equals 0. Our intercept, as we're looking at here, we can either look at it in the graph and see where it intercepts, which is right here, which is again a value at 1. And we can also look at our, excuse me as I move this down right here, as our growth or decay factor, the value in front of it, that is also going to be our intercept. And while again, there is no number written right here, just like there was no number written right here, but there is in fact a 1 in front of it, okay, we can actually insert a 1 right there if we wanted to. So the y-intercept is y equals 1. Oops, sorry, y equals 1. Okay. And this graph, as we look at it from left to right here, this is decreasing. Okay. And as you look at the table, this keeps getting cut in half, and then half, and then half, keeps cutting in half. And no matter how many times we keep cutting it in half, okay, it's going to keep getting smaller and smaller, but we will never get to 0. Okay. So that's exponential growth and decay. That's pretty much the basics behind graphing them. We're going to get some practice today in evaluating using these tables right here. Also being able to look at the graph and find key features and tell us exactly what's happening there. Thank you so much for watching. Have a wonderful day. See you guys next time.